this morning, what we want to be looking at is solving inequalities. But before we get into solving inequalities, there are a few things that we want to look at. The symbols, the notations, all right? So when it comes down to the symbols used, we're looking at this or that, or we have this or we have that, right? So these are the symbols that we use. Technically speaking, these symbols are actually, they're the same depending on where you're reading them from. So normally, I would say to people that, hey, if it closed down to you, for example, here, if I'm on this side and it closed down to me, I say less than. And if it opens up to you like here, and you're here, then you say greater than. For example, I would read this, x is greater than 5, because it opens to the x. But if you notice, it's closing down to the x, right? To the 5. It's closing down to the 5. So from this angle, I would read it 5 is less than x, right? So it simply means that these two signs here, none of them is a greater than or a less than sign. It depends on which side you're reading it from. Does it opens to you or does it close down or points to you, right? Now, when we have the symbols with the bar underneath, all right, so let us say we have a case like this. This is read, y is less than or equal to 10. Y is less than or equal to 10. What does this really mean? This really means that as you can see here, because it's pointing to the y, pointed part points to y, so we could say less than, all right? And the bar is saying that it's not just less than 10, it could be equal to 10 as well, all right? And if you're reading it from this side, then you would say 10 is greater than or equal to y. Have a broken line system. And broken lines are used to help us to understand when we have cases like a greater than case or just a less than case. If you're looking at it like x is greater than 10, y is less than 10. In these cases, 10 and 10 here, and let me change this. Y is less than, say, 5. 5 and 10 are not a part of the solution region, because an inequality is not just an answer, it's a range of answers, right? And so in cases like these, we would use broken lines. If we were to graph them, then we would have used broken lines to represent these, because these numbers are not a part of the solution system or the regions of the solution set. Broken lines are used when you're using greater than or less than, there's no equal to it. When do we use solid lines? Well, there are cases that we use solid lines. Solid lines. So when the lines are solid, like this, then we have cases like, okay, x is greater than or equal to 10. Or we could say, you know what, y is less than or equal to 5. Now, the fact that there is an equal in this thing suggests that, you know, the solution could be a part of the line, or it is a part of the line, and this number satisfies this condition, and so on and so forth. So when we have the bar underneath it, which means equal, then we use solid lines to represent that idea. There are some of the things that we definitely need to understand before we start solving. Now, how do we represent these? So let us say I have my number line. All right, so here's my number line. I have 0, 1, I have 2, 3, -1, -2. I'll stop there. If I want to represent, say, let us say I want to represent, say, x is greater than 2. All right, so if x is greater than 2, all right, let me just put this a little longer. If x is greater than 2, then if we're going to represent this on the number line, then we're going to have an open circle at 2. So right over my number 2 here, right there, I open circle. And then I'm going to point towards the region that is greater than 2. So greater than 2 is definitely to the right of 2. All right? And it goes on like that. What's the interpretation of this idea, though? What is the interpretation of this idea? This idea is suggesting that the solutions that we're looking for, the answers that we're looking for, would be to the right of 2 all the way to positive infinity. It goes all the way to positive infinity. All right? And so basically, this is how you would represent this on the number line. Seeing this on the number line, it really means that x is greater than 2. Now, what if we want to look at, a case like this? Maybe, so we have x is, let me use less than or equal to, say, 1. All right, so in this case, we are realizing that 1 is a part of our solution. It's less than or equal to 1. We're not going to have an open circle. We are going to close our circle by shading, right? So that's the difference. So we're going to shade and then we point into the direction. X is less than or equal to 1. So we're going to point in that direction, which means that this goes on forever until it reaches, well, it won't reach. So it goes on to negative infinity, right? So we're pointing from here. That means answers in this will be 1 and so on, less than 1, going all the way to negative infinity. Again, the symbol will help us to know whether we shade or not shade. So when the bar is not there, we cannot shade. When the bar is there, we shade. There are other systems like, what if we should combine ideas like, let us say that I have my number line right here. So here's my number line, right? On my number line, I have some numbers here. Yeah. And we want to look at the idea here. This is the idea that we want to look at. Right? So we want to look at the idea that x is let's say x is less than 3, and this same x is greater than or equal to negative 1. So this now, none of these will go to infinity because we are trapped between two numbers here, right? So we're going to have to be careful whether we open or close. For example, we have to look carefully. We're going to come to number 3 here as our marker. It's going to be open because we have a less than, so there is no equal, there's no bar, so we leave that. And then we come to negative 1 here, like that, and then we shade this, right, like that, all right? So we shade this because we're dealing with, we have the bar here. And as you could see, greater than negative 1 would mean that you're stepping to the right, and less than 3 would suggest that you're stepping to the left. So there is no arrow on it, but this is the region bounded by this idea. So we are trapped between the walls of positive 3 and negative 1, except the fact that we would include negative 1 in this solution and we exclude positive 3 from it based on the conditions. So those are some of the stuff that we really want to understand as it relates to solving an inequalities. It's just to understand how the inequalities work. Now, what do we need to do to solve an inequality? Well, definitely an inequality is solved just like how we solve regular equations. So let's look at this. This is saying that x plus 5 is less than 6. So x plus 5 is less than 6. What does that mean? It simply means that we are trying to find values that could come here that when we add it to 5, it's less than 6. I could think of many. I could think of a lot. But what the inequality is going to do, it's going to give us that margin, that response that we could take the margin and then we view the region For example, you will solve your inequalities normally. We're going to use the balance method. We need to get the x to leave it by itself. Therefore, we need to get rid of the positive 5. We will subtract 5 and balance the equation by subtracting 5 from the other side. Let's simplify this. We're looking at x is less than 1. So what does this really mean? This is simply saying that if we're on the number line, right? The number line. We have 0, 1, there's a 2, negative 1, negative 2, the arrows, right? Good. So x is less than 1, so here is our 1 and we point. All right? Definitely we're pointing to negative infinity. There it is, negative infinity. What this is suggesting that the moment you step to the left of positive 1, you're finding a value from the solution set that will make this statement true. Well, let us see if it really works. Let's try. So we're talking about x is less than 1. Let's try. Let us say less than 1 is 0. 0 plus 5, is that less than 6? Yes, it is true. Let's try negative 1. Negative 1 plus 5. Is this less than 6? Yes, 4 is less than 6. And you could try as many values that are in this set here. Alright, you could try any value here in this to see if it is true, and then you confirmation if you would have done the correct thing. Now, there are other questions that you can quickly look at, right? So basically, you solve these just the same. For example, let us say we find ourselves with 3x squared, or 3x should say, plus 5, which is greater than or equal to 2. We solve this ordinarily. This is a positive 5. We subtract 5, subtract 5. So we have 3x, which is greater than or equal to negative 3. There it goes. At this stage, what we want to do now is to just divide by 3, divide by 3. Our answer is saying that x is greater than or equal to negative 1. So what this is saying that is as long as x is greater than or equal to negative 1, we will get everything on the right side, left side, to be greater than or equal to 2. Now, let's look at this statement. It says 3 times x plus 5 must be greater than or at least equal to 2. Solution region, we start at negative 1, but x is greater than or equal to negative 1. So if you go on your number line, if you should look quickly on your number line, right? We're thinking of stuff like this is 0, 1, 2, negative 1, and so on. Greater than or equal to negative 1. So we are having it from negative 1, and we're greater than or equal to negative 1, right? So there it is. So what this is saying that any value you step to the right of negative 1 will make this statement here true. We could just try a few of them. We could try 0. Going that way. So 3 times 0 plus 5 should be greater than or equal to 2. Yeah, so 5 is greater than or equal to 2. That's true. Right? So that's one. We could do another. Let's try anything going that way. You could try number 2 to see if it's correct. So if x is 2, so we have 3 times 2 plus 5. Is that greater than or equal to 2? I think so. 6 plus 5 is greater than or equal to 2. 11 is greater than or equal to 2. So yes. So what the inequality does is that it gives you a number of solutions that work. Let's look at the one thing that is different. The one thing you do differently with inequalities is that you flip the sign if you multiply or divide throughout by a negative number. For example, let's say we find ourselves with 2x is greater than, say, 6. Right? Negative 2x should say is greater than 6. In solving this, what we're going to do is that we're going to divide by negative 2. Alright, but the moment you're going to divide by negative 2, so I normally say to people, like, if you know that you're going to divide by the negative 2, well, just rewrite it so that you can change the symbol. So look at this. I did change the sign. I flipped it around. All right, because if you're dividing by that, you're changing the whole game. What is less than becomes greater than, because we're dividing by the negative 2, not 2. You're dividing by the opposite of 2. And so because we're dividing by the opposite of the number, we have to change the sign. So x is less than negative 3. So the only difference when you're solving inequalities is if you're dividing throughout by a negative number, you flip your sign. Right? So this is one case. There's another case where you might have to multiply. So let's say we find ourselves with 5x over, say, negative 3, and this is, say, less than or equal to 10, right? Now, in this case, in order to solve this, we're going to have to get rid of this negative 3 here. So let's look on 5x divided by negative 3. We're going to multiply by negative 3. The moment we multiply by a negative number, my sign will flip. So here it is. It flips. All right? So it's going to be 10 times negative 3. Let's look. So this would have canceled itself. So 5x is greater than or equal to negative 30. All right, not bad. At this time, we're going to divide by 5, divide by 5. There's no flipping because we're not dividing by a negative number. So x is greater than or equal to negative 6. All right. All right. I think I need a little space right here. So x is greater than or equal to negative 6. And that's the point we're making. So the point is, if you multiply or divide throughout by a negative number, then the sign flips. Outside of that, solving an inequality, linear, in a straight line, basically we're doing, will be as simply as this. Right?